the importance of multicasting. We saw that if we do broadcast, it will take the traffic to everyone. And if you do unicast, you need to duplicate the packet as many as the number of receivers, which in turn going to increase the bandwidth utilization, process utilization, etc. So best is multicasting if you are planning to send traffic to a particular group. Right now, for multicasting, we learned that there are two important protocols. One, the protocol that will carry the multicast traffic to many hops, meaning you need something called PIM, protocol independent multicasting, so that your multicast traffic can go from R1 to R5. Yeah, so PIM is important to be there on every link between the source and the destination. Secondly, to join a multicast group, you need a protocol called IGMP, Internet Group Management Protocol. Now, what I'm going to do is I'm going to build this topology. Means I know I'm going to put the IP addresses and enable a routing protocol so that I'll have a reachability between R1 to all other routers. Using the reachability, I'm going to show you how the multicast works. You see, multicasting is a separate control plane according to the sender as a source and the receivers as a branches. Meaning, if I'll have a receiver here and a receiver here, then I need a tree. I need a routing table that has got this path and this path only. That routing table should not have routes to reach any of this router because there is no source. Sorry, there is no receiver. What I'm coming to say is I need a control plane that will steer the packet only through those links which are really appropriate to receive the multicast traffic, forward the multicast traffic. See, so I need a protocol and I need a table built based on what the protocol has discovered, and the table will be called as the control plane of multicasting because that is what we're going to decide where the packet should go. You see, this router should not send the packet on this link because there is no receiver there. Receivers are only here and here, maybe here also if you want, maybe here also if you want, you can draw. Now I have the receivers only on 2, 3, 4 and 5. So R1, when it wants to send any traffic to the group, meaning to those four computers, it should never send it on this link. It should not send it on this link. Yeah, it should not send it on this link. Meaning there should be a control plane that will control the flow. That will say via which link the traffic should move. So we need a multicast routing table. Yes. This table will be built dynamically with the help of PIM, protocol independent multicasting. So let us say, we got these computers A, B, C, and D in a group. To identify the group, let's say we want to use the multicast address 229, something like that. Oh, let me put on some unreserved registered one. Let me draw 239 111. To all these PCs, this four PCs, I have given this as the group ID. See, all these computers have got their own IP address, their own unique IP address. On top of it, they also belong to this group IP address. These four computers belong to this group ID. Now, these four belong to this group. They also have their own unicast address. I have not written any address. Say, for example, this computer's address is 2.2.2.2. Okay, 4 is already here, 2 is already, so let me give some address, just to simulate a computer, I have put a loopback address. Assume this loopback interface as computer. I don't want a LAN there. I don't want a physical LAN. That's why I have a loopback. So this loopback of R2, 3, 4, and 5, they have their own IP address. And whenever you want to send a unicast packet, you can send it to them. They will respond to you. But now I want this 4 loopback interface of this different router to form a group so that when I send some ping messages or anything, it can be a ping message also, an ICMP packet also to this address, all 4 loopbacks should respond me because they all 4 belong to one common group. So this is how we are going to test. We are going to make these 4 loopbacks to join a group, or to clarify your doubt, I'm going to enable multicasting only on 3, 4, and 5, not on 2, 4, and 5, not on 3. This is to tell you that you need not to have group members on every router in the path. Even if some routers don't have enrollment to the group, it is okay. So router 5 has got a group member who wants to receive the traffic sent from R1. Also 4, also 2. 3 don't have, 6 don't have, 7 don't have. So if R1 send any packet to this one, that packet can be an FTP packet, can be any sort of communication, anything that is sent to this address 239.111, all those 3 should respond. All those 3 should respond me. That's the proof to say multicast is working fine. We are going to ping and test it. So first thing what I'm going to do is put the IP addresses on all the routers. Enable a routing protocol. Let me do that first. Later I'll jump into multicasting. First thing is bring the devices up. Are they up? Yes, they are up. Now let's configure IP addresses on this device. Notepad. Enable config T interface loopback 0 IP address 1.1.1 00 IP address 10.12.0.1 interface F0/1 10.13. Interface F1/0 10.16.0.1. I would like to run OSPF IP OSPF 0 0. Done. So this is what going to go on router 1. Show IP interface brief. Show IP protocol. OSPF. Right. Show IP OSPF interface brief. It's running. Okay, R1 is ready. I'm moving on to R7 because it has got more interface than other routers. 7 and 5. Let's finish 7 and 5. Okay, no problem. We can also do 2. 2 also has got 2 physical interface. So let me do it for 2. Router 2 will have 2. And F00 will have 12.2. And F01 will have 24.2. And I don't have this interface, so I remove this. Okay, paste it on R2. Done. What next is router 3. F00 will have 13.3. F01 is going to have 35.3. Router 3 is ready. Now next is router 5. Let's finish 5, then we'll go to 6, 4 I'll do last. 4 has got only one physical interface. So let's finish 5. 5 F00 has got 35 5. And F01 has got 57.5. This is on router 5. Now 5 is over. Let's do 6. 6. F00 is 16.6 and 67.6. Router 6. We get another 2 routers. 7. F00 will have 67.7. F01 will have 57.7. This is on router 7. Alright, 7 is over. Now what is the left out of 4? 4 has got only one physical interface and one loopback. F00 is going to have 24.4. This is on router 4. Done. Alright, so I hope that there will be reachability between all these routers. I would like to test it from router 1. Ping 4444, source 1111, yes. Ping 5555 with the source 1111, yes. Ping 7777 with the source 1111. I got reachability. So we got our OSPF correct. Next is the multicasting. Please focus, please focus. I said we will join IGMP group on route 2, 4 and 5. How to join? You need a computer which will run an application that wants to join the group so that it can get all the packets that are sent to that address, 220, whatever the multicast address. I'm using, for example, 239.111. If anyone sends the packet, anyone in this topology, send the packet to 239.111. I want these computers on router 2, 4, and 5 to respond, but I don't have computers, so I use Lubax interface on R2, R4, R5 as the group member. Alright, source can be anyone. But in our example, I'll use R1 as the multicast source. Please pay attention. I'm going to go to router 2, interface Lubax 0, IP IGMP join group. This is the command. But in the real world, you may not be typing this command because you will be using some applications running on your computer that will join you to an inbuilt multicast address group that the developer has put inside the application. But in our case, we don't have any application. We are testing in a command line interface with the knowledge of networkers. See, before I put something, I want to show you. When I type show mroute, nothing comes. Show IP mroute, nothing comes. See the multicast table. I say control plane of multicasting is mroute table. Show IP mroute, nothing. I also want to type this command IP multicast routing. This is to enable multicasting. Even after typing that, I show you the same output. There is no difference. But now on R2, when I go to interface Lubax 0 and say IP IGMP join group 239.101, you will see some new information in the mroute table. Let me show you. You see, after I join a group, when I go and type this command show mroute table, okay, the reason why I don't see anything right now is none of this router interfaces supports multicasting. See, I enabled the multicasting globally. I'm not denying it. But that is not going to enable multicast support on the interface. For that, we need to enable PIM on the interface. So I'm going to do what? Interface range F. I use range because I have to interface. F0/1, or you can also type like this -1. Right, I'm on R2. I said this IP PIM dense mode. See, we are enabling PIM. This PIM has got two different modes, dense mode and sparse mode. I'm not willing to talk about this right now. See, this is one of the mode. I'm using PIM dense mode. I'll tell you what dense mode is in a few minutes, and sparse mode also. First, let me just simply enable PIM dense mode. Now PIM is running on this interface. Check this command now. Show IP PIM interfaces. See, these are the two interfaces that runs PIM version 2 in a dense mode. I'll talk about these version differences later. Now, show IP M route. Look at this. This is what I was talking about. When a PIM runs on the interface, meaning the device is ready to support multicasting. But this 224.0.1.40, we have not enabled on any interface. This is the multicast address, but we have not mentioned this address anywhere. Then why is this address coming? The multicast that we enabled is on loopback. See, show run interface loopback 0. We have enabled multicasting IGMP group on loopback. Why is this not shown? Why 224 is showing? What is this? See, in Cisco router only, you will find this address on all multicast supporting router. See, this was not shown before when I was not having PIM. But as soon as I have PIM, meaning the device starts supporting multicasting. IP multicast routing command is not enough. You also need to go to the interface and say IP PIM spares mode. As soon as you say that, the router says, I'm running PIM dense mode and I'm forwarding for PIM dense mode on these interface. But what about the loopback interface where we configured IGMP? We have configured IGMP, but why is this not shown there? Now, what is this address then? This is called Auto RP multicast address. There is a feature called Auto RP. We'll talk about RPs later. For RP's discovery, for automatic RP's discovery, you have this by default enabled on Cisco router. Do not spend much time on this one before I teach. I'll be teaching about these things later, 224.0.1.40. Don't think too much about this now. My question, what I want to think is, when I have enabled a multicast group, when I have joined a multicast group, why is this not shown? By this time you should have guessed. What is that? I have not enabled PIM on loopback. That is why it is not showing. So let me go and enable on loopback IP PIM dense. Now if you go and see, your M routing table will have your M routing table show IP M route will have this group that you have joined. Please focus on this portion. What does this say? This says that I have a receiver. See, receiver is what? Outgoing interface. I have a receiver who would like to receive traffic that is coming to this group ID. So router 2 knows that there is a receiver who wants to receive the packet that is destined to 239.111. But the router do not know the incoming interface, meaning you don't know from where the packet will be coming. As of now, we have not generated any multicast traffic to 239.111. So far, we have not generated any traffic to 239.1.1.1. So we don't see any group members. Sorry, we don't see any source members. We see only group member. This is a group member. Member is on loopback 0. What is the star? Means don't know. This position is for the source. If you will send any packet, from R1, that will become source here. source comma group member, S comma G. Always the first number in the bracket is source, but right now we don't know the source. But this router knows that I have a group member called 239.111 who wants to receive the traffic on loopback 0. Fine. Next is I'm going to repeat the same thing on R4. By using a notepad, I'm going to do it. Enable config T IP multicast routing, and then interface F, interface range loopback 0, comma F 0/0, IPIGMP join group. I think join group will be one word, so let me paste it and see. Router 4. See, it's one word. Join hyphen group 239.111. Yeah, and all right. Now let me paste this on R4, and then I'll show you now. Show IP M route. Something is missing. What is missing? PIM is missing. I made a big mistake here, you see. On these two interfaces, I do not want to join the group. So let me say no. Instead, what I want is actually I want to enable PIM. IP PIM dense. Alright, so only on loopback interface, I would like to join the group. See, that's the big mistake I have done. I want to this is on router 4. Okay, I think I have corrected now. Show IP PIM interfaces. Okay, show IP M route. Look at this. So this router also says the same thing. What is that? No. I think something is not removed it. F00. Yeah, correct. Router 4 says I have two interfaces where I want to forward the multicast dense mode, both on loopback and F00. Why on router 2 we did not see physical interface? Router 2 show M route. I think router 2 was not fully visible here. Oh yeah, here it is showing now. Earlier it was not showing this. Okay, now what is next is, let me finish it on R5. Dense mode need to be enabled on two physical and one loopback. So one physical is here, another physical will be this. And then loopback will join this. Fine, wonderful. Let me paste this on router 5. What? Alright. Now let me do it on R3. On R3, you see on loopback I am not going to do any join group. I'm just going to paste the rest of the thing. So on R3, we have PIM enabled. Let us finish it on R1. R1, there are many interfaces. So I'd like to put one more comma here and say F1/0. Dense mode. Yeah, that's it. Just we are enabling multicasting and PIM. R1 is also ready. What is next? R1 is okay, R3 is okay, R5 is okay, R6. And R6 also, there is no much difference. You don't need this interface there. We don't have in R6 only two physical interface and one loopback. This is on R6. Now next is R7. On R7, same. You see, all this router is properly configured with all necessary protocol to support multicasting. Listen, we all know the group member for 239.111 is only on router 2, router 4, and router 5 loopbacks. So if I go and check in R3, I should not see in the mroute table show IP mroute. I should not see 239.111 because there is no receiver. Likewise on R6, I should not see show IP mroute. I don't see. This is default. I told you for any cast RP. We'll talk about that later. Only on Cisco router you will have it. Even in R7, if you check show IPM route, I don't see 239.111. These are the three routers where you will find it. Router 5, show IPM route. See, it has got 239.111. But router 5 do not know the incoming interface, meaning router 5 don't know from where the packets are going to come. It don't know the source. And you see the mode that we have enabled is dense mode. Now I will go and try to generate some traffic from router 1. Please focus, focus, focus. Router 1 has also got no clue where the receivers are. Only you and me know the receivers are in router 2, 4, and 5. Router 1 or 6 or 7 has got no clue from where or to where the traffic need to be forwarded. Now, I'm going to use R1 as the source and I'll generate some traffic. I'll generate some traffic by pinging. You can also do any other way to generate some traffic. I'm in R1. I'm saying ping to 39.1.1.1. See, I'm going to show you two important things. You need to focus very well. When I ping, I'm expecting replies from 2, 4, and 5 only. 2, 4, and 5 loopbacks will reply me because I have enabled joined. I've joined IGMP on 2, 4, and 5. I've joined IGMP on 2, 4, and 5. So only 2, 4, and 5 is going to respond me back. No other routers. But surprisingly, you're going to see something also. Right now, R7 has got no idea about 239.111. But Surprisingly, router 7, router 6 and router 3 will also know about the source and the group member. Even though router 3, 6 and 7 has got no connection to this multicast address 239.111. Router 3 is going to forward the traffic to router 5, that is how router 3 will know. Router 6 and router 7 will be knowing because the mode that we have enabled is what called as dense mode. What is dense mode? Dense mode is a mode where the multicast traffics are forwarded via all the PIM interface even if there is no destination to receive the traffic. Listen, R7 has got no destination to receive the multicast packet because there is no group member in R7 and R6. But it is called as dense mode. Dense mode is nothing but flooding and pruning. All the routers will be receiving the multicast traffic. 3 will receive it and forward it to 5. 6 will receive it and will forward it to 7. 7 will receive it and it will drop. Why? Because 7 also don't have a member. 6 also don't have a member. 7 will not forward it to 5 because for R1 to reach 5, 7 is not a shortest path. It will go straight from 3 to 5. Now you see, I'm going to generate the packet and then I'll show you what exactly I mean. I'm sourcing from Lubeck 0. As I said, you see, only these 3 routers are responding. 2, 4 and 5. 2, 4 and 5 has responded. No others have responded. That means others have not accepted the packet. See, they received a packet but they did not accept it. Meaning R3, if you go and see, earlier when I was showing you, R3 was not having any information, but now it has got the information. R3 says, yeah, there was one group member and that member is connected via F01. Is it true or false? Of course it is, you see. For R3 via F01 only there is a group member which is behind R5. And the incoming interface was F00. Yes, of course it was coming from R1. So router 3 knows that yeah, there is one group member, there is a sender, there is a source. And now R7 if you see, and R6 and R7 also surprisingly knows about that. But the problem is because there is no receiver, it has pruned. Whereas in R3, it is not showing pruned. It shows I am forwarding to router 5 via this interface. I am forwarding it via this interface. But R7 says I am not forwarding, I am pruning on F01. Why? That is not the best route to reach 5. And let us see R6. R6, where are you? Here. R6 also says I also pruned. I sent it to R7. R7 did not respect it because R7 I think he don't have a member to receive it. So he did not respect me. I'm also pruning. I'm not going to send him anymore. But when I ping again, it will try sending it once again. And now if I go and show you, it's saying it's pruned. See, every now and then they will forward. After some time, they'll try forwarding. And then only they prune. This is what called as flooding and pruning method, dense mode. Meaning if you ping, everyone will receive the packet, but all will not be responding you because they don't belong to the group. R6, R7 and R3, they don't respond. Even though they receive packet, they don't respond R6 and R7 prunes it. R6 and R7 says I received it, but I am not willing to receive it anymore. That's called pruning. R3 received it, but R3 cannot respond because R3 don't have any group configured on it. It forwarded to R5 and R5 responded and R3 forwards it to R1. The response of R5 is forwarded to R1. That's how you got the reply here from 5.5.5.5. Now you see I'm going to remove from R5. See what happens. I'm going to remove from R5. R5, where are you? If I remove on the loopback, interface loopback 0, IP, IGMP, join group, I cancel. Now if you check the mroute table show IP mroute, I still have this, but I need to refresh. Okay, yeah, but the loopback is not a member. The loopback is not a member to receive because I removed it. But for your satisfaction, I can clear IP mroute table. Show IP mroute. Now you see, it's fresh, refresh. Now let me go and ping from R1. If I ping from R1, only 2 and 4 should respond. No one else should respond. Look at this. Because the group member of R5 has been withdrawn. Okay. Now let me join a group on 7. See what happens. Interface loopback 0 IP IGMP join group 239.101. Now if I ping from here, you will see 7 also responds. Look at this. So multicast packets are delivered only to those who have joined the group, not to anyone. Yeah. All right. So we have seen how to configure IGMP and how to configure PIM and the impact of PIM and IGMP configuration. What we are going to see next is there is a drawback in what we have done now. What is that? Flooding happens to all the PIM enabled interface. Earlier I did not have any member on 7 and 6, but the packet was going there and it got pruned. Yeah? Which can be avoided by another mode called sparse mode. The mode that we have enabled is dense mode. This dense mode is not that popular because of the flooding and pruning nature. We are going to have a source based, this is source based tree based on the source that control plane has been built. We are going to have a shared tree concept called sparse mode, where there will be a router called rendezvous point RP. Using the RP, we can limit the flooding of multicast traffic to all the PIM interfaces. So wait for another class to understand better this multicasting. I have given you a good introduction of multicasting in the previous class. In this class, I have shown you how multicasting works, what results you can expect. In our next class, we are going to see the actual multicasting called sparse mode, which is what more popular. But I'm not saying what we have done is less important. No, this is also important. Dense mode is also seen in various applications. But spats mode is more optimal, scalable. Please ask me question before we close.
So, I want to ask, so IGMP is the protocol which helps these nodes to join.
Join, correct.
And PIM is what enables the node to talk to the multicast, I guess.
PIM carries the multicast traffic from one PIM neighbor to another PIM neighbor. So between these router R1, R2, R4, they all have formed PIM neighbor. So if you see, there will be a DR between these two. Show IP PIM neighbor, you see. R1 says I got this 3 neighbor. So using the neighbor sheep, they know that there is a receiver who wants to receive all multicast traffics.
So, okay, so first thing is the reachability through some routing protocol between the whoever is the main router and the other receivers. The second thing important is the PIM path from the sender to the receiver.
Yep.
So if you do a PIM neighbor on the R2 and R3, then there should be a R7 and R5 and R2. So
PIM needs to be enabled on every link in the path between the source and the receiver. Only then a control plane can be built.
and control plane is the
MRoute table.
okay. So it requires basically PIM also and then IGMP on top.
IGMP is only to enroll to a group. The scope of IGMP is local to the router. It is the PIM, the one.
Enables you join some group. Yes, that's it.
Yeah.
And unless PIM is able to so from the sender to that router, unless PIM is there, that IGMP is of no use.
No use, very correct. The M routing table will not come. The routes won't be there to reach source comma group member.
But why is IGMP then called as a control plane? So it should be
No, I did not say IGMP is a control plane. M routing table, IP M route table is the control plane. PIM helps to build a M route table, the control plane. I said PIM helps to build. I did not say IGMP. But IGMP will be the destination address based on to which destination to which the control plane is going to show you the path. The multicast address is the destination. Where is the destination? Wherever IGMP is enabled. Wherever we have joined the multicast group. For our discussion here, the IGMP destinations are 2.2.2.2, 4.4.4.4, and 5.5.5.5. Because they all have one common multicast address 239.1.1.1.
can this work in just a flat layer network?
See, layer 2 multicasting is different. This is layer 3.
Oh, I see. So it's a different layer.
Yep. All right. Any other question from others? Right. If no question, please go through the previous video and this video. You will have some connection. And still, if you have questions, bring it to me in the next class. Do all that I have done today. You will have a better understanding of what you learned today. Thanks for joining.